Now, on occasion, we do like to rationalize the numerator rather than the denominator. However, this is much, much rarer. It really doesn't happen that often. In general, when we're simplifying with radicals, we always like to rationalize the denominator and make sure there's no radicals in the denominator. However, occasionally it's helpful to be able to rationalize the numerator. So I wanted to show you two examples in this video of how to do that in case you come across it. And it works the same way. So here, instead of trying to cancel the radical in the bottom, I'm trying to cancel it in the top. So for a basic square root problem like it is here, again, there's no adding or subtracting. I'm just going to repeat whatever that radical is. So there's no difference in the procedure. It's exactly the same. It's just that you're thinking about the numerator and how to cancel that instead. So in the top here then, let's see, I end up with 7 times 7 is 49, so root 49. In the bottom, before I keep going, I should have done a little bit of pre-work here. I do notice that root 49 is the same thing as 9 times 5. So root 9 is actually 3. So I'm going to rewrite this as 3 root 5 times root 7. And then I can multiply whatever's inside the roots together to get 35. So again, if you see something that you could do up front that you think will make your life easier in the long run, go ahead and do that. It's much easier than trying to multiply 45 times 7. That's going to give me a really big number. Now the square root of 49 is also 7. So I end up with 7 over 3 root 35. If I could do anything with that root 35 to break it down further, I would. But I can't here. So notice in this case that the numerator is the one that doesn't have the radical anymore rather than the denominator. Again, it's not that common that we do this. It happens sometimes though. Usually we try to rationalize the denominator, but you could really do it on top or bottom if the problem calls for it. In the next example, I see cube roots in both cases. I don't see anything that I can simplify here. If I try to put it back together, it doesn't help me either. So I'm going to go ahead and just start rationalizing. Again, I'm trying to get rid of the number in the numerator, which is different. So I want to think about how do I cancel the numerator out. Now, because I have a cubed root here, I'm going to go ahead and use a cube. And cubes are a little trickier. Anything higher than squares, you're not just repeating it. You have to really think here. So I want to think about, well, what are my possible cube roots that I could use here? And I see I have a factor of 2. Well, if I had 2 more of those, so if I had 3 2s, right, that would be 2 cubed, then I could get that to cancel. If I only have 1 of them, so I'm missing 2. So I'm going to use basically 2 squared here, which is 4. And the reason I use 2 squared is because I want 3 of them so I could get them to cancel. There's 1 here, and I'm going to bring in 2 more. With my x's, I already have 2, but I would like to have 3 to get it to cancel. So I'm going to bring in 1 more x that's missing. And that is what I'm going to multiply the top and the bottom by. So in the top here, I then have the cube root. 2 times 4 is 8. X squared times x is x cubed. In the bottom, I have the cube root. 5 times 4 is 20. And then I have an x, y. Now in the top here, the cube root of 8 is 2. And then the cube root of x cubed, those are going to cancel out, is just x. Again, I'm going to assume my x is positive. Actually, I don't have to worry about it here because it's a cube root. If it was an even root, we'd have to make sure the x is positive, but you don't have to with cube roots. And in the bottom, there's really nothing I can do. There's no way to break down that root 20 that's going to be helpful. So this is going to be my final answer. All right, let me do one more here. And again, we're going to stick with rationalizing the numerator. So here I have a square root with a plus sign. So you want to think back and you are going to use your conjugates here. So you're going to use the same thing, but instead of using a plus in the middle, you're going to use a minus. And this works for those square roots when you have adding or subtracting. Now you do have to be careful because you're going to have to go ahead and distribute through. So again, the multiplying becomes more complicated here. In the top, you have root x times root x, and then root x times -2. Then I multiply the 2 through. And on the bottom, I have to distribute the 5 through. So I have 5 root x, and then 5 times -2, so plus 5 times -2. When I simplify x times x is x squared. Here I have a -2 root x. Here I have a +2 root x. And 2 times -2 is -4. In the bottom, I have a 5 root x and a -10. Now what happens here is my square and my square root are going to cancel. Again, I'm going to assume my x is positive so that I don't have any imaginary numbers right now. And I would just have an x there. Notice that these are like roots and they're opposite signs, so they will cancel. You'll get 0 there. And I have a -4. And then on the bottom, I have 5 root x minus 10. And this is fine as a final answer here. If you wanted to, you could factor out a 5 from the denominator, depending on how the problem would like you to write it, because there is a 5, in both factors here. So that would be an alternative way to write that answer. And again, you're trying to get the radical to go away from the numerator here. So when we say the word rationalize, it means make that radical go away. So you can do it either the numerator or the denominator, although as I've mentioned, the denominator is much, much more common. But this does come up occasionally, so it's good to see it done both ways.